Okay, it is part 6 of Laplace transforms. It is division by t. In the previous part 5 we have seen multiplication by t to the power of n. But here note that I am talking about only t power 1, division by t power 1. So if we know the Laplace transform of f of t and it is f of s, then the Laplace transform of f of t by t, this f of t is divided by t, then we have to integrate this f of s. I'm just writing u here with the du. Even if you write s with the ds, it is one and the same. But because we are going to substitute s again, so for making simplicity, the variable is used as u. Then when you substitute s in the place of u, it becomes somewhat simple. If it is s and if you are substituting s in the place of s, some people will get confused. That is why the other variable is used. There is nothing wrong in writing f of s ds, where the s to be substituted with the infinity and s as the upper and the lower limits. Okay, let us see the problem on this one. Evaluate L of, that is the Laplace transform of sin t divided by t. Now we know what is L of sin t. Okay, let us do it now. We know that L of, if you don't know this one, you see the part 1. Okay, fine. Now L of sin t is 1 by s square plus 1. That is nothing but equal to f of s. Therefore, by using this particular rule, L of same sin t by t, then what we need to do, whatever transform is there for this one, that is this 1 by s square plus 1, I am integrating from s to infinity ds. The other way to write is 1 by u square plus 1 into du. Anyway, that's one and the same. So you take the screenshot for this one. Okay. The last step was this one, which I have copied again here. Now the integral of 1 by s square plus 1 is tan inverse s. We are integrating it from s to infinity. Now that is tan inverse infinity minus tan inverse of s. Upper limit substituted and lower limit substituted. That s is again s. Suppose in case you write a u square plus 1 du, it will look like tan inverse u from s to infinity. That is why some people write integral s to infinity f of u du. Anyway, that is so simple. Now coming to this point, tan inverse infinity is pi by 2 minus tan inverse of s. So this is the Laplace transform for sin t by t. Once again, sin t has this much of transform. When sin t is divided by t, that transform we will integrate from s to infinity with respect to s. Okay, so you can take the screenshot now. Okay, let us see how to evaluate this one solution. L of Laplace transform of e power minus t into sin t divided by t. The thing is that it's a product divided by that t. You can calculate the Laplace transform for this completely and then divide with the t. That is one option. The other option is you can write it as e power minus t times of sin t by t. So first what we'll do is we'll calculate the Laplace transform of this, and then using the first shifting theorem we will adjust for e to the power of minus t. Now what is L of sin t by t? That is pi by 2 minus tan inverse of s. Just now we have done. In the examination you need to calculate this first. First calculate a Laplace transform of sin t, that is 1 by s square plus 1, and then integrate it from s to infinity for division by t. Then you will get this one. Now we are ready with this Laplace transform. Therefore Laplace transform of this sin t by t when multiplied with e power minus t, then you know that this complete transform as it is pi by 2 minus tan inverse s, you have to change s as s plus 1, because it is s minus of minus 1, so s plus 1. So finally it is going to become pi by 2 minus tan inverse of s plus 1. This is how we manage when t is divided. In the case of multiplication with t, we will differentiate the transform. Here we are integrating the transform, and there we are differentiating the transform. I hope you understood. This is the end of multiplication by t and division by t. Multiplication by t done in previous part, now division by t. So till now we have covered first shifting theorems, scaling property, multiplication by t and division by t, and linearity property in the previous part 2, and in part 1 the definition and the related list of some standard functions we have done. Okay, for the next topic you please watch the next video.